Hi, I'm Jeremy Vendetti. And so we're here at Yaalstrick Bar in the Fraser River. So this is the location of the gravel to sand transition in the Fraser River system. If you look upstream here, the river is gravel bedded. The width of the river is on the order of several kilometers wide, and the flow depths at high flow are about 5 meters. If we look downstream here, the river gets narrower, and it goes from being an anti-branching channel upstream to being a single thread channel downstream. The river goes from being several kilometers wide upstream of the gravel sand transition to being about 500 kilometers wide downstream. It goes from having a 5-meter depth upstream to having a depth of about 15 and in some places up to 20 meters deep downstream of the gravel sand transition. And so the gravel sand transition happens right here, immediately across from us at Yaalstrick Bar. And there is a change in the bed material from being 10 millimeter gravel to being about 350 micron sand. So it's a big step. It goes from 10 millimeters down to about 0.3 millimeters. And the interesting thing is, it happens over a very short distance, over just a couple of channel widths. So these kinds of transitions are interesting because the gravel sand transition happens in all rivers worldwide. The other thing that's very interesting about it is the only abrupt grain size change in rivers. In most rivers, grain size changes as you move downstream, and there's a gradual downstream fining of the material that makes up the bed of the river until you get down to gravel that is about 10 millimeters in size, and then there is this step change from gravel to sand that usually happens over just a couple of channel widths. So there's two interesting parts here. One is it happens in rivers worldwide, and it is the only step change or abrupt gravel transition in grain size in rivers. So the big question is why does the gravel sand transition happen? This is a problem that fluvial geomorphologists have been working on for many, many years. Going back, probably the first papers that come out on this were from the 1950s. There's been a number of theories put forward for why gravel sand transitions happen. One of them has been that the gradual downstream fining of sediment and the related sorting of sediment as you go downstream from a cobble-bedded river down through a gravel-bedded river, that actually leads to the gravel sand transition. Because there is a related phenomena that is referred to as the grain size gap in rivers. And so there is a perceived gap in grain size distributions of riverbed sediments from about 1 to 10 millimeters. And so if you look at the distribution of gravel and sand on the bed of a gravel bed river, what you'll normally find is that there is an absence of material in that distribution that is between about 1 and 10 millimeters. So the idea is that with downstream sorting, if you're decreasing the grain size as you come downstream, and then there's a missing component of the grain size distribution, the river has no other choice but to shift from being gravel to sand, because there's nothing that exists in between the gravel and the sand-sized materials. Another theory for why the gravel-sand transition occurs is that it is caused by preferential abrasion. And so what happens there is, or the thought of what happens there, is that 10 millimeter particles are fundamentally unstable, and that they are preferentially crushed from 10 millimeters down to 1 millimeter, and that's what causes the gravel-sand transition. Now, I will note that that has been demonstrated to be incorrect experimentally, that you can in fact take 10 millimeter particles and break them down into, say, 8 millimeter particles and into 5 millimeter particles and so on. And so there's no real reason why the abrasion would cause the grain size gap or the step change or the abrupt gravel-sand transition. Another idea that's been put forward for the reason why gravel-sand transitions occur are backwater effects. So you can imagine as a river comes down through a gravel bed reach, if it begins to approach the ocean and there is a backwater or there is some tidal effect, that rivers will then go and change from being gravel bedded to sand bedded. And the reason why is simply that the river is no longer competent, does not have the capacity to continue to carry the gravel, and so then the river shifts from gravel to sand bed. Another idea that's been put forward is the idea that gravels shift from gravel bedded to sand bedded because of wash load deposition. That is, the deposition of sands that are carried as wash load in gravel bedded rivers. Once you come down to the end of the gravel, the idea is that then that wash load begins to move as suspended bed material load, and the river transitions from gravel bedded to sand bedded. So part of that overall theory is the idea that gravel bedded rivers tend to have a steeper gradient. That steeper gradient is necessary in order to move the gravel. But if at some point you run out of gravel, you simply don't have any more gravel supplied from upstream, and the river is fining as you go in the downstream direction, you're eventually going to reach a point where there's just not enough gravel to keep on moving it downstream. And because gravel bedded rivers are steeper than sand bedded rivers, you will have a shift from gravel bedded to sand bedded. And that happens because the material that is carried as wash load in the gravel bedded reach shifts to being bed material load downstream, and that occurs across a break in slope between gravel bedded and sand bedded rivers. And I will caution you, that theory is largely mine, and so it is my favorite. So my research group has been working on this problem of why gravel-sand transitions occur for a little over 10 years now. There is a postdoc working in my research group named Lizzie Dingle, who's been doing a worldwide analysis of the locations where gravel-sand transitions occur. And the thing that she has found is that they always occur within a couple of 100 kilometers of mountain ranges where the gravel that is coming out of the mountain range essentially runs out. It's a simple volume problem. You produce the gravel within the mountain range, and eventually you run out of gravel some distance downstream from that mountain range. She's also found that gravel-sand transitions happen at backwaters. And so a backwater is where a river is flowing downstream and it eventually begins to feel the effect of lakes or the ocean, which then decreases the capacity of the river to transport sediment, and in particular to transport gravel. So both of those things, running out of gravel and the backwater effect, both or either of them will produce a break in the gradient of the river, because again, gravel-bedded rivers tend to be steeper than sand-bedded rivers, and also the backwater causes a steep gravel-bedded river to adopt a lower gradient. And so we think the abruptness comes from that break in slope, where we have wash load that is carried in the gravel-bedded reach turning into suspended bed material as it comes into the sand bed reach. So one of the questions we've had to face in our research is, where does the 1 to 10 millimeter material go in river systems? There is this common observation in gravel bed rivers that there is a gap between gravel and sand between about 10 millimeters and 1 millimeter. And then there's this other observation that we see here in the gravel sand transition, that 1 to 10 millimeter material does not appear to be there. So there's been various theories proposed to explain this, including the mechanical breakdown of 10 millimeter particles to sand-sized particles. Of course, that's possible, but one of the things that we have found is that in very energetic environments, like on beaches, we find that there exists this material between 1 and 10 millimeters. So it doesn't really make sense that it would just disappear in rivers and not disappear in other environments due to mechanical abrasion. So we have showed that there is a very narrow range of conditions in which rivers with a median grain size of 1 to 10 millimeters can exist due to suspension dynamics. And so when we say median grain size, we mean the 50th percentile of the grain size distribution. There are very few rivers that exist in that grain size range. And the reason we have proposed is that there is a threshold hydraulic condition where you either get a gravel bed river or a sand bed river. But if you have bed material in between that, the river would tend to shift to either a gravel bed river or a sand bed river and would not be stable for very long in that range between 1 and 10 millimeters. So one of the arguments that we've been putting forward is that 1 to 10 millimeter material exists in rivers. It's just that you never have a river that has a median grain size of 1 to 10 millimeters. So we think that 1 to 10 millimeter material exists. It just happens to be split upstream of the gravel sand transition and downstream of the gravel sand transition. Bringing this whole discussion about gravel sand transitions back to the Fraser River, the big question is, well, why does the gravel sand transition happen in the Fraser River? And it turns out many of the things that I've discussed all happen in the same place in the Fraser River system. So first of all, the river basically runs out of gravel that is supplied from the mountain range right here at Yaalstrick Bar. The other thing that happens is not too far downstream from here, near Mission, British Columbia, we have the backwater effect from the ocean. And the other thing that happens is that right across from us here is Sumas Mountain, a very large, very big piece of rock that the river essentially runs up against. And all of these things happen in the same place. The river runs out of gravel, the backwater effect kicks in from the ocean, and Sumas Mountain is a pretty big piece of rock to push all that gravel around to get it out into the lower mainland of British Columbia. And all those things lead to that gravel sand transition in the Fraser River.